Hello everybody, have a good day. So, we are now in the last part of the design of multi-storied building frame, part 5. The thing is that I have tried to give you idea that how we will proceed, because if we go step by step, although I have tried to give you all the aspect, but even then also possibly still there is a gap, possibly that is why I have noted down all the values, so that by seeing the video itself you can solve one problem. We are coming to this one here, whatever we have discussed, that particular one here, just we are up to this position. So, we are considering that all of them, that means here for the frame whatever we have done for that frame, just quickly let me tell you that for that frame, that whatever we have done, all the points here, please note down all the points whatever we have noted down here. So, we are having that 16 columns and remaining there are 40 elements. So, we are having 24 beams. So, 1, 2, 3, each of them 6 into 4, so 24. So, that means just note down this particular we can note down here. So, 24 beams and 16 columns. Why we have made it here 16? That means here all of them one, this is another one, this is another one, this is another one. So, now we shall find out what is the value we have got it here, that particular one we are interested, and we have 32 nodes, that also need to write down. What we do actually here, any software whatever you can have, the thing is that this is not a big thing, you can write your own program and you can find out on your own that you can do it here. And this one I have done it in a single one. Now, let me tell you the secret of that, whatever we have discussed, that particular one I shall tell you. The one long back in 2004 we started, and many of you actually, those who were there, they asked me that a software, and that let me write down today again, that is actually your say, this is the one that it has come from dead, wind, earthquake, and live load. So, this particular one we are having, actually I am still working on that. It was originally written in C, then C++, and now it has come back to that Python. So, Dual has become now Dual Phi, that particular one we are having, that is in Python. So, I have written that particular one program, and this one actually, that is why I am telling you, if you are interested you can write your own thing in Python, and that is actually available in internet, you can download it and you can find out. Just for your information I would like to say, use 2.7 version that you can use it. There is version 3.3, 3.4 like that also, but this version you can use it here. So, just to introduce this particular one here, that actually I have written, that is why I have shown you that stiffness matrix also, because that one you can write down on your own, because already you are having certain exposure, and so you can use it there also, you can do it. So, coming to this one here now, let me quickly go through it. We do not have much time, of course, but anyway, so let us go through it, this particular one here, whatever we have given here. So, then we are getting that your say nodal data that we know, and then that means we require coordinates. So, that means in this particular solution we always require say related to nodes and we require related to elements. So, that particular one we are having here. So, we can find out, and then we have got it here up to 32 nodes, and that is summarized here. Elements also I have given you here, elements that one by one floor wise, actually I have given the first column 1 2 3 4 that particular one element, then 5 6 7 8 9 10 11 12. So, I have given the connectivity, that how the nodes are connected, then 13 14 15 16 17 18 19 20. So, floor wise, first floor beams, second floor beams, third floor beams and roof beams. That is the input data we have given. For that you will get displacement, as you all know that all of them 0 because it is fixed. So, node number 1 2 3 4 which is at the ground, that is actually your fixed. So, that all of them are fixed here. So, that is why all of them 0, but you will get the displacement here, that particular one at the top floor you can get the displacement, this particular one at lateral, you see the lateral displacement you are getting here, lateral displacement here you are getting, that you can find out. Here you are getting that value. So, we can find out here that for different cases we can get different values that we can find out. So, node number we can get it here, displacement for different node ID, that we can find out here. So, 5 6 7 8 like that, that actually we do not require that for our calculation. So, then 12 13 14 15 just given, 16 17 18 19 20 20. So, this is the third floor nodes, third floor, then roof nodes, so just node number 1 ground, that is 0, that is why. So, 5 12 19 and 26, those nodes I have given. So, from there you can find out the displacement 3.088. This is load case 3. Load case 3 means actually you are having that load case 3, that particular one you are having here. So, we can find out here 3.088, 6.372, 9.191, 1.0. So, that means it is going more, actually this particular value it is coming more here, that particular one you can, this is the lateral displacement that you can find out here. So, this is for dead load and this one for your live load, that way you can find out here, just to give you idea. Just please bear with me, just let me give you the so this is the one, just to give you the same thing. This is for earthquake load, this is another one. So, you can find out this is your x value. So, this value is increasing. So, that means if you plot it here, you can find out that plot. So, it may be something like this particular, this is one, then another one, then another one, then other one. So, which is coming more here, that you can find out. This is the value you can get it, and that we can find out here for different, that is the one, that node ground floor less, then more, then more, then more, that you can find out. This is the value we can find out here. Next one we shall get it here, that you would say axial force and your bending moment, shear force, other value also we can get it. So, we can find out those values here, that we can find out here. For different load cases actually we have got it here, that is say element number, and then on the basis of that we have got it here. So, these values we can get it here. So, what I can do actually here, I shall show you that, then it will be clear. So, let me show you here that value, that will be easier, because compared to that at least I can write down something here, though it is coming little because of the white, that one. So, this one node number 2, that is the load case. So, this is for dead load, live load, earthquake load. Similarly, this one for element number 2, so what we shall do it here, we are interested here, this particular one, you see that this is at this node, this node, this node and this node, that is the one I am interested actually for this particular one, that column, this column only we are interested. So, what we shall do it here, that particular one, let us write down that, then it will be clear. So, dead load. So, element number means we are having here elements So, this particular one, this is your node number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and element number 1, then 2, 3, 4, 5, 5, 6, 7, 8, then 9, 10, 11, 12, then 13. That means, for ground floor columns, we are interested for the ground floor columns. That we are interested. So, from this one we shall take it as 336.8. So, we shall note down here 336.8, that is the one we have got it here, that one, and then this is for dead load. Then for live load we are getting it here 145.6. Earthquake load, it is negative the other way. So, 38.93, that is the 1 kilonewton, and we are getting it here, that moment, this moment, or here I can show you this one here, that minus 1.776 minus 3.464, that is the top one. So, I shall note down here at the bottom 17.76. Now, what does it mean this one, actually that particular one here, that if you take it as like this, this is actually positive. I mean to say like this, if you make like this right hand coordinate system, if you make like this actually that particular one we can consider that is called actually your say right hand side, that way you consider that is called positive. So, your this one the thumb which will go towards the other axis. So, here just to give you idea how to read it. So, this is your x, this is your y and this is your z. So, if is there, that means here with respect to z we consider that particular one here. So, that z is towards me. So, then we will consider this particular one. So, that is the one convention we shall follow in that to read that particular value. So, we have got this particular value here, this value we have got it here dead load. So, means at this particular point we are getting this value and minus 17.76, then minus 7.67 and then 55.67. So, then we can consider this one case, we can consider dead load plus live load we can consider. So, that means we can take it here 336.8, 145.6 multiplied by 1.5 multiplied by 1.5, which will give me the value of PU. This is for dead load and live load. For MU minus 17.76 into 1.5 minus 7.67 into 1.5, this one will give me that MU or rather MUX. So, this value if we get it here PU and MUX. So, from there getting that value, that means then I can go for column interaction and on the basis of that we can find out. So, then we shall go for the this is not fitting properly. So, this is that column interaction one, whether I have just shown you one curve, that is the column interaction. That means, here whether you will choose this one, that where that it is in the opposite sides, or you will choose the other one where we are having in the all four sides. So, on the basis, that means then I can get that value. So, then it is now clear that how we will proceed that particular one here, how we will proceed that particular one from this value the other one how we will proceed. So, your table you find out, just to give you idea that you see that one in SP16 whether it is 0.1, I have taken 0.1 or not, on the basis of that you can find out 0.1, 0.05 d dash by d I mean to say. So, d dash by d 0.1, 0.15, 0.2 on the basis of that, or whether you are interested to provide the reinforcement in opposite sides or you are providing that one in the other way, this particular one the same way, that value 0.05, 0.1, 0.15 and then 0.2, which is the value of d by d. So, on the basis of that you have to choose, so that you can find out from this table, that means from the analysis you can do it. So, this is the thing that how we follow, how we proceed with your calculation, that we go ahead. So, this is the one how we shall do that particular one here like that. Next one is I should like to say, so like that you will get all those things. Now, that for the columns, that means we do not require all of them, you can find out that. Next one we are having in 17, this 17 we are having these values. So, we are interested with the mz, because in beam we are interested with mz and we are interested with Fy. Fy is the shear force. So, those values you are interested, from the one combination we can find out those values, we can find out here. So, like that we can find out for all the sections, wherever you are interested you can find out. You can choose the maximum one also, that way you can find out and we can choose. So, like that whatever is required, that I have given you here, just slowly that particular one here. So, you can note down, I think. One second, please please allow me. So, this is the one for element 1, 2. then for 3 4, then for element 5 6. So, first two for the first column, left side column, this is for the intermediate left column 5 6. I am going up from 5 at the ground floor, then in the first floor level 7 8, then that column is over, then 9 10, then 11 12, second intermediate column is over, right side column 13 14, 15 16. So, you can get, so that means all the columns now over. So, out of that columns you can find out from one intermediate column and one outer column, that you can choose that which one having the ground floor obviously a maximum. So, that you choose it, and on the basis of that you find out. So, this is the one we do it. Then elements, first floor elements. So, 17 18 means actually outer one, 17 18 means actually this particular one we are having 5 6 and 6 7, 7 8 8 9. So, let us say I am interested at 6. So, if I am interested at 6, just how to read, let us come back here. So, element number the 17 6. So, this is the value, that moment we am getting it here. So, that particular moment I am getting it here, that particular one here, for this particular one I am getting that moment here. So, like that 18 also I can get. So, that means here you see the span moment for node number 6 for element number 17 and node number 6 of element number 18 having the same value, but opposite. Why opposite? Because why opposite? Because this particular one here, the bending moment whenever you are writing this particular one here, this is the bending moment for this particular one. So, like this, like this. So, that is why you are getting opposite here. So, one positive, the other one negative, that one negative. So, you can see this particular one side this way, another side other way. So, that is why you are getting one positive, one negative, that way you are getting here these values. So, you will find out always 5.8 minus 5.8, you will get it here, or say 2.48 minus 2.48, that is the one value, because in the span you will get like that. Similarly, 19 20, that you will get it here, these values, same way you can check it. This is for the first floor, 21 22, first floor is over, all the values you can find out. That means you have to choose the different section, you have to find out the bending moment, and then you have to check. Then second floor 23 24, out left side beam, this is the middle beam, then out right side beam, then again third floor left side beam, then we are having say middle beam, and then right side beam. Now, in the roof, left side beam 35 36, again you can see these values 6.38, 6 minus 6.38, 2.71 minus 2.71. So, like that we can find out that particular one here, 1.17 minus 1.17, 37 38 middle beam of the roof, and finally that top roof, the right side of the beam. So, all those things from there you can get the maximum bending moment, maximum shear force, and then on of that particular section, and then on the basis of that you can find out. So, this is the one that means if you are done this one, then you are through. Now, out of this analysis there are many things that I have told you that your live load may be different, then I have considered all the floor loads same, that is always same. So, because of that your values will be different, but if you write down the program all those things, so it is very easy to solve it, easy to do that particular one here. So, next one, so support reaction here. So, we have got the support reaction here. this particular one here. So, let me just simply write down that support reaction first. One of them is because support reaction is very important here, just to tell you that support reaction is very important here, just to tell you that number 1, for whatever forces were given, one thing I think I should mention, that whatever forces are given, that is always in the local coordinate system. Your global coordinate system is like that, this is x, this is y, this is z. For element for B columns, this is your x, this is your y or y dash, and z remains same. So, this particular one, whatever we are getting, this particular one here, that whatever we are getting, that we shall do it, we shall find out. First of all, what you have to do it actually here, you have to check that Fx, that vertical force, whether this value, that 1, 2, 3, 4, this value if you add, then whatever you have got that value, it should match with that. That means 336, 145, 460, 246, 460, 246, 336, 145, all of them, that if you dead load and live load, that one should match, and it matches. Similarly, for the lateral load, you see that it is not Fx, the load applied in the x direction, this is the one, that y, that one in the column, because it is in the local coordinate system. So, that is why this value, this value, this value and this value if you add, then you should get the value of that, whatever you have got the lateral force, that Vb, it should match with that, and it matches. So, that is the one actually you should find out, that particular value that you should check. So, this particular one is very, because this summary support reaction required, that whether your calculation is correct or not, that it will show you that. So, now the thing is that design of beams, just only I shall give you one example, that particular one here, because it will be a process of repeating the same process will be done. So, we have taken the element number 17, first floor span, 1.5 mz DL and 1.5 mz level, that particular one. So, 57.995, 1.5 into 24.797. So, multiply by 124.189 kilonewton meter, that you have got it. So, this is the one, for this we have to check. Then we are getting it here, say 25 Newton per square millimeter, that particular value we are getting it here, say B 300, D 400, possibly that it will be 500 anyway. So, that can be anyway, with that 400 let us check whether are coming or not. C is 25 clear cover. So, effective date 367, that we have got it. So, 0.138, that is the one value. Moment of resistance due to concrete 0.138 FCK BD square 139. So, more than 124. So, it is all right, more than that. Leverham J 0.5 plus this particular one we are getting it here, this particular value 0.83. So, we are getting here area of tension required 1129.6. We have provided 6 number 16 dia bar 1206.4 due to steel as per the clause of IS 456 MUSP. So, that particular one which comes 137.76. So, just to inform you that we have got the value moment mu, let me write down here, moment mu 124.189, which we have got it from calculation analysis. We have got 139.185 kilonewton meter due to MUCB. I mean to say the balanced, for balanced case we have got it, that particular value, and then we have got it 130.76. Why I have written that one, 130.776 kilonewton meter, that is due to MUSP. I mean to say that whatever the for steel, the idea is that these values should be more than that. So, mu less than MUSP less than MUCB, that means it is under reinforced section. So, mu less than MUSP less than MUCB, that is called actually under reinforced section, that one we can consider here. So, that means here MUSP provided more than MU, so that means it is safe. Further MUCB, that particular for concrete, that is more than that MUSP, that is under reinforced, that particular one, it is there. So, this is the one that we would like to show you here. So, finally, I would like to say that this example is taken for a demonstration. More detailed analysis can be carried out considering different roof load. Load of transverse wall is not considered in calculation of lateral load due to earthquake, because the beam you will design on the basis of your say that table given in IS 456, that is the one. It is possible to solve the problem using commercial software. Here an attempt is made to show the calculation at different stages. This document is prepared by programming in Python. Whole thing, whatever your analysis, everything that is done in, I have given that particular one in Python, that we have done it. So, with this finally that IS codes, whatever the course, IS 456 2000, IS 875 1987, IS 1893 part 1 2002, there are five parts, all those things are there. So, this one actually that your design of by multi-story frame, that one by I have given by the plane frame actually, and here no commercial software is used, everything is done on your. So, you can also try on your own. If you try, it is a very simple thing, and I suggest that you use Python, you download Python and see, it is very useful and interesting also, and very easy to learn, and with all those things it will help you to learn reinforced concrete design also. With this finally, thank you very much.